Hey guys, today we are looking at 2.3 Focus and Directrix. I did split this up into 2 days because it is a lengthier lengthier section. Takes a little bit more getting used to, so I did split this up into day 1 and day 2. So today we're looking at day 1. And with today, we're going to be focused on having my vertex staying at the origin. So I know we've spent some time in the last couple of days. You guys have been working on the gizmo, just kind of getting acquainted with the idea of a focus and a directrix. So just a quick little reminder of what that means. So again, we have a different way of defining what a parabola is, or how we find the points of a parabola. Usually, or what we did in Algebra 1 and earlier this chapter, it was based on just taking our x value and squaring it in some particular way to give us the points along our curve. Now we also can create these points on my parabola using a point and a line that are fixed. So if we took a point, which we'll call the focus, and a line, which we'll call the directrix, and all of the points on my parabola have to be the exact same distance from those 2 points. So what we call them, they're equidistant from that point, which is the focus, and the directrix, which is that line. So if you look here in my example down here, all of these different points that I've found on my line or on my parabola, I've got a point here, I've got a point here, and I've got a point here. If you remember from geometry, these little tick marks indicate that those are congruent segments. So that means they're the exact same distance all the way throughout. We know, again, distance from between 2 points we could calculate using distance formula. And then this distance here from my point down to my directrix, we know that the shortest distance between any 2 points is a direct line. So when we're measuring a distance between some point and a line, that has to be perpendicular to it. Straight up is the closest path. So that's just, again, kind of emphasizing where this comes from. What's going to be important for us to know is that the distance between the focus and any point on my line being the same tells me that for this specific point here, if we look at, let's erase these, so the ones that I just have, this point that I have highlighted in black here, which is of course my vertex is exactly halfway between my focus and my directrix, right? Because if these are congruent line segments here, that means the vertex is halfway between the focus and the directrix. So that's going to be important moving forward, knowing what that is. Now, that distance, in this case, between the focus and the directrix, the focus and the vertex and the directrix, we call that distance P. From the vertex up to the directrix, or up to the focus, is that distance. This one right here. From the vertex to the focus, that's what P is, which means this, if I'm going the opposite direction, it's also a distance of P, but you're going down P. So again, the kind of how we adjust that formula will make a little more sense when we get to it. But that's it. Everything else we label the same way. My vertex is still at h comma k, but P is just that distance from my vertex up to my focus. So box 2, and I'm going to give this to you in a little bit of a cleaner organization. Not that this one isn't clean, but I'm going to combine this, box 2 from the notes today with another box from next week when we do day 2, because this is a really busy little box here with lots of information in it, but it's really, really important stuff, because these are our formulas for how we go through and can figure out what our equation is going to look like, or what our graph is going to look like based on the equation, or vice versa. So in this, again, we can see we've got our vertex. In this case, we're focusing today on my vertex staying at the origin. And if we look going up to my focus, means my ordered pair now, my point, is 0 comma P. Because again, P is that distance from my vertex up to my focus, or down to my focus, in the case of a downward opening parabola. So in that, if you know what P is in your equation, you know everything that you need. We also do have, so if you notice here, for my vertical axis of symmetry, that means I have a parabola opens up and down. You've got y equals 1 over 4p x squared is my equation. So that 1 over 4p is just kind of replacing that a value we looked at earlier this chapter, my number that tells me whether it's a vertical stretch, shrink, or reflection. But now we know specifically if we want to focus in on the focus, 1 over 4p is the equation that we can use to find where my focus is. And again, p is just what tells us how we get from my vertex to my focus. So obviously here, then my equation for my focus is just 0 comma p, once you know what that p value is. My directrix is y equals negative p, because again, if my p is positive 2, my directrix has to be 2 units underneath my vertex, which would be a negative 2. We also do have the option here of having a horizontally opening parabola now, because we don't have to worry about our x being squared. It could be our y that's being squared, in which case it's the same thing. Literally the only thing that changes is I flip-flop x and y. So now it's going to be x equals 1 over 4p y squared to get a horizontally opening parabola. So that information is going to be available to you again in a kind of a cheat sheet form, but for right now, just make sure you guys have that to reference off of. Because as we go through in the boxes 3 and 4, we're going to actually be applying these ideas. So for box 3, we're identifying and graphing. They just want us to identify the focus, directrix, AOS of negative 4x equals y squared, and then graph the equation. So in this case, in order to be able to do these things, I need to have my equation in the format I'm used to, which is either x equals something y squared or y equals something x squared. In this case, I'm going to have to divide by negative 4 on both sides to get my x value by itself. So the equation I'm actually starting with, and just to kind of make it match what I'm used to seeing, I'm going to write this as 1 over negative 4 y squared instead of y squared over negative 4, just so it's got that fraction format out front. So in this, we just have to figure out what p is, right? Well, I guess we do my AOS right away. My AOS, this is a y squared, right? So if you look back up here, if you forgot, a y squared means my AOS is y equals 0. It's going to be a horizontal line at the x-axis. So my AOS is going to be y equals 0. I need my focus and my directrix. Those are things I need to identify before I can graph. So here, both my focus and my directrix are based off of that p value. So I need to figure out what p is in my equation. Which, the way that I would suggest doing this, because it's 1 over something, right? We know that 1 over negative 4 has to be equal to 1 over 4p, which really means negative 4 equals 4p. Now these, a lot of times, especially for you guys, you can probably just look at the equation and say, hey, I could just identify really quickly what p has to be in order to get it to match that. But for some of them that might be more complicated or not necessarily nice clean numbers, this process that we're doing here is a way that you can be able to find that definitively. Because here it's really easy to see that p just has to be negative 1, right? Negative 1 times 4 gives me a negative 4. So my p value equals negative 1. So that means my focus is negative 1 comma 0. And my directrix is x equals positive 1. Because again, I'm just plugging those into my formula from up above. My p comma 0 is my focus. X equals negative p is my directrix. So since my p was negative 1, my x equals has to be positive 1. And now I just get to go and graph these. So I know my vertex is at 0. My focus is at negative 1. My directrix is a solid line here at positive 1. My AOS was y equals 0. So I've got that going for me. Now for these, I don't necessarily need 5 points, but I do need you to find at least 2 others, right? 1 on each side, so I know the general shape of it, whether it's steep or narrow. So the way we can do that, I'll just change up my color, just plugging in a different number. So I would say negative 1 is probably an easy one to plug into. So if I plug in negative 1 for my x value, ooh, no, I lied. I want to pick y values here instead of x values. Because when I look at my equation, I'm picking out squared. Like if I pick out an x value, I'm going to have to multiply by negative 4 and then take the square root of that, which is not the nicest. It's not the meanest, but not the nicest. So you can pick out whatever y values you would want to, because again, we're going to pick y values and get x values back out. So here, if I pick 1 over negative 4, let's just do 2. So here, 1 over negative 4 times 4 equals negative 1. So when my y value is 2, my x value is negative 1. So negative 1 comma 2 is that point right there, which means because of my AOS being at the x-axis, I also have a point right there. So the reason I picked 2 here, and you can kind of use your mathematical logic. If you don't pick out a number that ends up working out nicely, it is what it is. As long as you estimate where it is and approximate where it is, you'll be fine. But here I looked at what my denominator was. So the reason I didn't pick 1 is because 1 squared is just 1. So I'd end up with a fraction. But I recognized because that if I plugged in 2 there, 2 squared is 4, which is divisible by my denominator. So if you can do that kind of little just like quick mental math and be able to pick out stuff that's going to work nicely, then that'll save you some time and headache later on down the road when you guys are graphing. But now that I have those 2 points, I go through my vertex, I go through my 2 points that I just figured out, and we're good to go. That's graphing it. Okay, so box 4, writing your equation. Now, writing your equation, this is actually the easier one, because all you need to figure out for your equation, if you look back up here to what our equations look like, you only need 2 things. You need to know which direction it opens, so whether you're using that top equation or that bottom equation, right, whether it's x squared or it's y squared. And then the only other thing you need right now, because your vertex is at the origin, is just p. That's the second thing you need. So in this case, all I need to figure out is which direction it opens, which in this case is vertical. So I'm using y equals 1 over 4p x squared for my equation. And in this case, from my vertex to my focus is 1, 2, 3, 4, 5 spaces. So that means my p equals 5. That looks like a 6. 5. So then putting it all together, your equation would just be y equals 1 over 4 times 5 x squared. So we would want to simplify that into y equals 1 over 20 x squared. And you're done. All right. Homework is page 72, 4 through 28 evens. Again, for today, all you guys are going to be working with are parabolas at the origin, so at 0, 0. So that's much simpler. In day 2 that we'll work on coming up here for 2.3, we're going to be working on taking this idea and shifting it around to different spots around my graph. So if you guys have any questions, as always, make sure you guys are reaching out and letting me know. Otherwise, have a great day, and I will see you guys soon.